today we're going to talk about the average value of a function. So first I want to think about, what does average value mean? If I said you had a bunch of numbers and you want the average of those, you would add them up and divide by how many there are. Well, the average value of a function, we're going to add up all the numbers, and the tool we have to do that is the integral. So I'm going to take the integral from a to b of f of x, and then I'm going to divide by the range. Okay, so 1 minus b over a times the integral from a to b of f of x is going to give us the average value. So let's kind of look at an example, and maybe this will help some understanding. Okay, we're going to find the average value of f of x equals 2x over 0 to 4. So according to our formula, that's going to be 1 over 4 minus 0 times the integral from 0 to 4 of 2x. This will be 1/4. The antiderivative of 2x is x squared. And we're going to evaluate that from 4 to 0. So that will be 1/4. 4 squared minus 0 squared, so 16 divided by 4 is 4. So let's look at this graphically and see if that helps us out here. 6, 8. So here is 2x from 0 to 4. So this value here is 8, this value here is 0. So you have anywhere between 0 and 8. Well, according to our formula, the average of those would be 4. And that should make sense that, especially for this line, that 4 is the halfway point here. So half of the numbers are below 4 and half of the numbers are bigger than 4. So that is our average value. Okay, find the average value of 1 over x squared from 1 to 3. So that's going to be 1 over 3 minus 1 times the integral from 1 to 3 of 1 over x squared. So this will be 1/2. The derivative of 1 over x is negative 1 over x squared. So the antiderivative of that will be negative 1 over x. So 1/2 negative 1/3 minus a negative 1 over 1. So negative 1/3 plus 1. So that'll be 2/3. So we get an average value of 1/3. Okay, find the average velocity. Well, that's just saying find the average value of this velocity function. So that'll be 1 over 5 minus 0 times the integral from 0 to 5 of v of t. Okay, so we'll take that antiderivative, which will be 16t squared. Evaluate that from 0 to 5. Let's go and put the 16 there. So this will be 5 squared minus 0 squared. So 5 squared is 25. If we multiply that by 16/5, we will get 80. And we don't have units, so we'll go with that. All right, so now we're going to compare that to, or see how this looks like in an actual AP problem. So Joanna jogs around a straight path from t equals 0 to 40. Joanna's velocity is given by the differentiable function v. Selected values of her velocity are given in the table. Use the data to estimate v prime. Okay, so v prime is the instantaneous rate of change at 16. So we'll use values close. Remember, derivative is just the slope at the point, so we'll do the slope near here. So I'm going to do v of 20 minus v of 12 over 20 minus 12. So this would be 240 minus 200 over 8. So on the AP exam, I would stop here, and you might not even do that part, but we'll go ahead and do this. It doesn't ask us for the units, but sometimes they do, so we want to practice that. But it's the units on the top divided by the units on the bottom. So the units on the top are meters per minute. The units on the bottom are minutes. So that would be 5 meters per minute per minute. All right, our next one. Using correct units, explain the meaning of the definite integral 0 to 40 of v of t in the context of the absolute value. Okay, and then we'll find it. So what this would be, we're doing the integral of the absolute value of velocity. Okay, we've seen problems where if we have the graph of velocity and we find the area under it, that gives us the distance. Okay, the reason we have this absolute value part of it is because not all of our velocities are positive. So this is going to give me the total distance traveled from t equals 0 to t equals 40. Okay, it multiplies the rate times the time, so that gives us the total distance. Then it wants us to approximate the value using a right Riemann sum. Okay, so we're going to approximate with a right Riemann sum. So in our table, the widths of the rectangles are going to be the change in t's. My heights, if we're doing a right Riemann sum, is going to be evaluated at the rightmost value. All right, so let's bring down our chart. So our first width is going to be 12. Our first height at the right end of that is going to be 200. Next width is 8. Next height is 240. Next width is 4. Next height is negative 220, but we want the absolute value, so we'll multiply it by 220. And then the next width would be 16 times 150. Now you could, instead of actually doing the math on these ones, you could literally say 20 minus 12, 24 minus 20, and so on. So this would be meters. And we're just going to leave it just like that. Bob is riding his bicycle along the same path. For 0 to 10, Bob's velocity is modeled by this guy, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at t equals 5. Well, that means we need to find the derivative. And we'll evaluate that at 5. Okay, so that's that. If you simplify it, it's 15, and this would be meters per minute per minute. Okay, part D, based on the model B from part C, find Bob's average velocity. Okay, well, here's his velocity. So his average velocity will be 1 over 10 minus 0 times the integral from 0 to 10 of t cubed minus 6t squared plus 300. Okay, so we're going to have 1/10. Then we're going to integrate this. So 1/4 t to the 4 minus 2t cubed plus 300t evaluated from 0 to 10. So this is 1/10. 1/4 10 to the 4 minus 2 10 cubed plus 300 times 10 minus 0, 0, 0 if I plug in 0. So I'm going to go with that, and I'm going to leave it just like that because you did not have a calculator on. So the average velocity will be in meters per minute. All right, a metal wire of length 8 centimeters is heated at one end. The table gives selected values of the temperature, T of X, in degrees Celsius of a wire heated from one end. So it's hot at 0, and it gets cooler as we move away. Estimate T prime of 7. So we just did a problem like this. I'm going to use those. So 55 minus 62 over 8 minus 6, which we can leave it like that. This would be a negative 7 halves. It does want the units of measure. So if they ask for that, you are getting a point for that. So the units on the top are degrees Celsius. The units on the bottom are centimeters. So it's decreasing, the temperature is decreasing at about 3.5 degrees Celsius per centimeter at that point on the rod. For B, find an integral expression for T of X for the average temperature of the wire. Then we'll estimate it using a trapezoid sum of 4 subintervals indicated in the data above. All right, the integral for the average value is going to be 1 over 8 minus 0, since that's how big our rod is, times the integral from 0 to 8 of T of X dx. Then we'll estimate this with a trapezoid sum. So we're going to have 1/2. The first width is 1, and then we evaluate the heights, 193 plus 1/2. The second width is 4, 93 plus 70. The next one's width is also 1, 70 and 62. Okay, and then last one is 2, 62 plus 55. Okay, and again, we're going to leave it just like that. But you know what I did forget? Okay, the 1/8. Don't forget the 1/8. Okay, the last part of the problem, find the integral from 0 to 8 of T prime of X and indicate the units of measure. Okay, well, the integral from the fundamental theorem says, that the integral of this is going to be the antiderivative evaluated at 8 minus the antiderivative evaluated at 0. Well, that's going to be T of 8 minus T of 0. These are pretty common type problems, is understanding that fundamental theorem. We don't have a function to deal with, just a table of values. Okay, so we have 55 minus 100. So that's negative 45 degrees Celsius. Now, what was that? Okay, well, the 55 was the temperature at the end of the rod. 100 was the temperature at the beginning of the rod. So what's 55 minus 100? Well, that's the difference in the temperature. The temperature dropped 45 degrees from x equals 0 to x equals 8. So that is the average value of a function and how we see it in various AP problems.